Okay, so welcome everybody again. We're going to continue from where we were last time, and the plan today is to finish this tutorial and also get into dependencies and go over them as well. So just to pick it up from where we have been, so we're discussing how, for example, you could inject scheduler options to the generated job script, and this is one way. The problem with this way is that one could say, okay, but this requires that you know that you have, for example, Slurm behind the scenes. And for this reason, there is also another way that is a bit more portable that could be adapted to different backends. And that's what you can achieve with this flag here called extra resources. So these are type of resources that you can define in your configuration and associate them with any type of options, scheduler options. It could be number of GPUs that you get, like with GRES or processors, processor types and things like that. Let's see how this is done. So we have to modify the configuration. And we add a section that's called resources inside the partition. I'm going to explain you in a moment how exactly it works and what it means. Oh, yeah, I need to. Okay, so here essentially is a list of resource objects, let's say, that each one has a name. So this is the name that you're going to use to access that resource from within your test. And then there is a set of options that will be passed to the scheduler. And there you can have also placeholders, which you can fill in your test. And that's quite flexible because you can name your resources as you want. And for example, in our real tests, we have a resource named num switches, I think, or switches, which essentially asks Slurm to pass the -- switches option, which restricts the job allocation to a certain set of nodes under the same switch. But the good thing is that although you can specify those in your test, like we do here, if I'm running on a system that there is if this resource is not defined, it's going to be simply ignored. So whereas here it's going to be there. You have to put it yourself. If I am on that system, then use that or the other. So this is a bit more flexible, let's say. And now let's say it in practice. I think the test is called. Here, another thing is if you pass both the -L and -R option, the -L option, which is about listing, it will always take precedence. So, okay, let's see if we essentially got it. Apparently, if the test passes, it seems that it has put the memory, because we're testing that the actual out of memory message is there, but we can have a look. See, and let me know if the font is too small. I think we were in the GNU environment, and that's the memory limit with resources test. And there you have it. So without having to know how the option is. I find this is quite useful, especially if you had, for example, a cluster with KNL nodes, or a mixed cluster that you don't want to define partitions, or for some tests. Yeah, it's another, I mean, more test specific resource specification, let's say. So that's about it. And one other thing is how, for example, you could modify the parallel launcher command. Sometimes you might need to pass options to the parallel launcher like the MPI run or the SRAN. And I mean by options that they are not the standard ones like the -N4 or things like that, which ReFrame automatically generates them if needed based on the combination, based on the launcher you use, you have specified in your configuration file. For example, in this case is an example of an affinity test. Well, actually doesn't, it just run an affinity test. It doesn't check exactly affinity. So there we want to pass the minus CPU bind equals scores to the launcher. Now, this you can do it. Let's open the test so it's not to be here. So again, very, very similarly to what we did with --mem, again with the hook after run, you can access the launcher through the job, so serve.job.launcher, and add to it some option. And there we add this. Now, if you ask me whether you can do that more portably, I would say no, you can't for the moment. Not for the moment, you can't. That's the thing. So there, if you want to guard it against different systems, you have to do it manually with if I am on that system or on that partition. So this is going to add those options to the launcher, and I'm going to run this right now. We call that affinity. Oh yeah. I forgot to add our cluster. CN. And also, for example, here I can let me put let me put here EUM. I think. I'm not sure if no CN. Yeah. So that's it. Let's run it. So again, sometimes as a hint, when you have affinity tests, always test all the different environments, because different compilers and different OpenMP runtimes make different assumptions, and they can do different placements. So we have seen differences, for example, between how Intel and, for example, GNU interact with the SRAN affinity. So whenever you have an affinity test, just keep this in mind. So output, ReFrame, CN, let's pick the GNU. So you see how it generated this. So depending on the backend, if you had, for example, MPI run, the ReFrame would have MPI run -N1, minus NP1, etc., and then it would add those options that the users pass. Now, another thing is, what if you want to test a debugger? And so debuggers usually you have to wrap the parallel launcher command. So here is a case on how you can do that. So you can basically replace the launcher and basically wrap it. So this is a kind of pseudo launcher that takes the actual one and wraps it with your own command. So DDT offline here. And then it will generate this thing. I don't have an example about this because that would require, for example, have DDT on the cluster, but this works. Another is closely related to this is, for example, when you want to test something that has its own launcher. For example, there is IPyParallel, Greasy, or some visualization software. They do come with their own parallel launchers that they essentially behind the scenes, they leverage MPI run or SRAN, but essentially it's not the user-facing thing. So there you can still do, here in those cases, this is the trick. So you can set the executable, which is the custom scheduler. For example, if we take Greasy, it's going to be Greasy. Pass any options there. And then you replace the actual launcher that ReFrame would normally use with the local launcher. The local launcher is just basically emits nothing. It's like the one when you run your executable, which is the empty string practically. And with this thing, you can do that. So actually, this get launcher thing takes the name of the register name of the launcher. Now, the register names of the launchers, you can find them in the documentation. So those are the names with more details, what exactly each one does. So it will give you back this object that then you can also play with it if you want. But that's the way in those cases. Another thing is, okay, how about if I want to add more srun commands, more parallel launcher? So in this example, we have a test that we're going to run multiple srun. We're going to get an allocation of certain number of nodes here, 4, and we're going to have 4 srun commands, each one running with from 1 to 4 number of nodes. You could theoretically see that, I mean, there are cases that you might have to pack multiple srun in a script, or when you, for example, you would need to do a scaling thing, but again, then you could also use parameterized tests. But let's see this example for the sake of it. So here is, again, you have to fiddle a bit with this launcher, job.launcher. So again, you prepare everything before you run. And there is here a small thing that's the launcher has a method. All this is documented in, if you go into the references, so you can see the exact documentation of all these functions. So here you just say, okay, give me the command that you would run based on this job. Now it always takes the job because the job might have the information about num tasks, etc. And some launchers may want that information, like the npran. You need to pass, for example, npran minus np. And what this thing will give you back is the actual command, which then you can use to add additional options, like we do in this case, where practically, as you will see, it will return essentially srun, and then we just add more options and our executable. And here we generate everything in the pre-run. You could put it in the post-run. Remember that the pre-run and post-run are things that they go before the srun or parallel launch executable command. Now, again, I would need here, I always forget. And now I'm gonna run it. Ah, yes. Okay, we have an error, but let's see what it says now. Let's examine it. It says that's a sanity error, and there we have an assert equal, and instead of getting 10 things, we get 1. Now let's go back to the test. Okay, what we're testing. Okay, so we have, yeah, the node pattern is different because on Dane they're named NID, but here they're named ReFrame. So I'm gonna do it like that. So we can even say node pattern, have a generic one that matches everything. And then let's make the test a bit more generic. If I am undained, then my node pattern equals this thing. If I am on the, oh, sorry, the ReFrame EUM. My node pattern equals its ReFrame. Okay, and then let's put also this part here. And here we simply say, okay, that should be good. That should do the job. Okay, so it works. Also, it seems that our test, our sanity check works. But let's also examine a bit the output. Built-in, what's the multiple test? Okay. So you see, so everything here is in the pre-run thing, and you get as you would expect. And yeah, here is also the output. We could even be more strict here in counting the instances of how many times we've seen the same node and things like that. But let's keep it simple. Okay, change of topic. Flexible regression tests. Yeah, I need to rush a bit. So a flexible regression test is a test that sets the num tasks to either 0, like in this case, or to a negative value, which means that I will need at least that number of tasks, at least minus num tasks. So here it's a hostname check that I'm gonna spin it, and it will essentially run in all the nodes. So let's
environment only using gray here.
Am I using gray? Ah, okay. Yeah, that's a. It should have been using built-in. It's just that. Yeah, I forgot to update that. That's a bug. It's a bug in the documentation. So that's an interesting. Yeah, that's an interesting feature for diagnostics because it will span. By default, it will get all the nodes that they are in, all the nodes that they are idle. And for example, here, let's examine the output. How we call it? Hostname. So you see, we got the whole cluster. Now, if multiple of you run the same test, and for example, the time my ReFrame checks it can't find a node, then it will make the test fail. But the other cool thing about it is that it will only, for example, now it doesn't take all the nodes of the whole cluster. It takes the nodes that they correspond to that partition that you are accessing. So if you have constraints, if you have -p partition, etc., it will all take it into account. And I forgot to say that this is only valid for the Slurm backend. And of course, the local backend, because there's always one node there. So another interesting thing is if now I'm going to pass an option directly to the Slurm -j partition equals, I think, lower, right, Victor? I'm going to get only half of the nodes because it will include that option.
Yeah, but it's down. I put it down. Sorry.
Okay. No, I'm gonna do the thing. If I put a node list here, and I'm gonna put just 10 to 12. I think I have called this thing. I have to quote it so that Bas is happy. Now we're gonna just take these three nodes. Let's see. Yeah. So you see, so that's very useful, for example, when you have like a reservation of nodes or you want to run a benchmark on a specific node and things like that. I find it quite useful. And then you can do several magic here. For example, one thing that I didn't mention is Yeah, so the num tasks attribute of the test will be set by the framework as soon as it gets the actual number of nodes. So then you can use that with this deferred expression here to check that you actually got the number of nodes that you, or do something with the number of nodes that you got. For example, here we check that we actually got an output from all the nodes. That everybody, we got a printout from everything, from everybody. Since we still have 10 minutes only. So moving on to how you could, for example, test containerized applications. You can use that with, you can launch containers with ReFrame. And first thing you need to do is adapt your configuration. And there is this kind of object here, the container platforms, which is a list of the actual container runtimes that you have. So in this case, we just have Singularity on your laptop. You could have like also Docker. And that's another thing that goes here per partition. And actually what you say here is the type of the container. Oh, okay, here it is, sorry for the. And in case there is a module that you need to load or to set some environment variables as well. In our case, it's already installed. So we don't need to load anything. So that's how it is from the configuration side. And then from the test side, it's this one. So it's very similar to the build system in how the way you write it. Let's also put here our guy. Programming environments practically, that's why you need a built-in environment that loads nothing for this type of test as well, because it doesn't matter. So then you say container platform Singularity, and then there are several things that you can add there. So there is the image, there's some common to all of them, but there's some others that they're more specific to each platform. The image and actually the commands you want to run. The self.executable is not going to be taken into account. And also you can specify a working directory, which honestly, this I don't remember. So, yeah, I think that this one, yeah, I think this is where it's going to bind. So what ReFrame does, it mounts the stage directory inside the container. And I think the work there is where it's going to do that. But I need to check that. So here, and the nice thing is that then you can still use the machinery that ReFrame gives you with the sanity patterns to check what has run inside the container, because essentially that stage directory has been bound inside the container. And let's do this. Let's run the test right now. So
There's a question.
Okay.
Has the in hand.
Yeah, just give me a second just to run the example, Kenneth. Containers. Okay, let's see first what it generates. Built-in. Okay, this is what we generate. So an SBUTS thing, and then srun Singularity exec, and there you see how we bind the stage directory inside the container as workdir. And then we just run what it has to be run. So that's what we do. And let's see also the output. So you see you got the output as expected, which this thing is what ReFrame then looks at in your sanity checking. So yeah, Kenneth, if you...
Can you easily parameterize over different container images as well? So say you want to run the same tests but in different images.
Yes. You can have a parameterized test here, and then you can parameterize over the image. Yeah.
But that's something we're interested in for EasyBuild. So running EasyBuild in different operating system versions, configurations.
Yeah, it's you have the whole machinery of ReFrame. So the only thing that it ignores is the self.executable, because then it wouldn't be, the semantics wouldn't be so straightforward. So we said we just put the commands in here.
Okay.
Okay, so moving to another chapter that's it's 5 minutes. We can't make it, but I don't know. Can I get up? I mean, can I have like another 5 minutes?
Yeah, you can. But we will have to end the stream definitely 10:02, so 10 before the hour. So if you still want to have time for some questions
10
at the end,
hour. So that means I have like 25 minutes.
Yes, then we have to end the stream. So, and ideally that includes some questions as well. But.
Okay. That's fine. I thought we had like 5 minutes or something for some reason. So, okay. So yeah, dependencies. That's a nice chapter. Now, before, I think it's first explain a bit some things before going into dependencies, so that you understand why dependencies with ReFrame and the different tests are not as straightforward as you would, for example, imagine them for like a build system like EasyBuild or Spark. Let me. I think. Okay, just give me. I'm going to show you in the documentation. I'm going to point you to some things instead of. Has some nice figures. So one first thing is how ReFrame executes tests. That's one thing that you need to keep in mind. So here is you write your test, and you say that this test is valid for those systems and for those programming environments. Now, when ReFrame loads the test from the disk, it instantiates it. So it will call its init method. That's one thing also to keep in mind. If no matter what, it will instantiate it, even if it is meant for the system you're on or not. The filtering happens just afterwards. So it will then filter the tests based on the options you pass, on what are the programming environments that need to be tested, and so on. And from this point on, actually, it generates, I think this should be changed now. So after it loads it, it generates combinations by cloning the test with different programming environments and with different partitions. So it creates proliferation of test cases, as we call them, out of your test, which is those that they will eventually sent down to the runner, which will be responsible for running for the whole run. So the runner basically takes those, doesn't know anything about the test except just an API, and just schedule them for running. But it doesn't know anything about the test. All it takes is the test cases, which is the specific instantiations, or not exactly instantiations, but clones, let's say, of your test. Now, the dependencies work at that level, but actually you write your test at a higher level, but the dependencies essentially work at the test case level, not at the test level. Now, before going here, so conceptually, okay, let me open first a test with dependencies. Oh, no, let's here. This one is enough. Let's go later to the examples. So here, what constitutes dependency to create dependencies is this thing. So depends on, and you put the name of the target. So here, T0. And that conceptually is this thing. T1 depends on T0. However, if in reality, T0 is not just a single test, it has multiple test cases. And the same for T1, it has multiple test cases. So the question is, when we were designing that, okay, do we need to provide, to give control as of how the individual test cases are connected? And we came to the decision that yes, it's better if you can do that, because, for example, you might not necessarily want to depend on another test case on an irrelevant programming environment, for example, or that has run on an irrelevant partition. So you define your dependencies conceptually, but then they are kind of expanded in a more detailed graph. And there are different ways that you can specify those connections. There are shortcuts for those connections. So there is the by case, which is the default. So as soon as you say that T1 depends on T0, then practically this means that the graph is like that. So I only depend on the same on T0 when I'm on the same partition and on the same programming environment. There's no things like cross-cutting here, arrows. Of course, there are different ways. So fully, that could be the obvious, for example, implementation that gives flexibility. I will not start running T1 until all the cases from T0 have started, but you can still do that. So depends on takes a how argument, which says how you depend on the other guy. So by fully means that none of the test cases of T1 can proceed if it will proceed only for the cases of T0 have finished. And by finished, we mean finished, like completely the pipeline, both sanity and performance and cleanup, everything. And then you have different by partition, by environment, and so on. I'm not going to go into the details here. So that's a basic thing to understand with dependencies. So it's not just this thing, which is the conceptual, where it's usually where the build system like easy build stop, because there we have from this one for us, T0 and T1 are essentially multiple things that we're going to schedule and run. So we need to know what is the relation here. So let's go to the examples. So here we picked the OSU benchmarks for the dependencies, and we split it in like let's say three broad categories. One test that downloads the test, the code just for demonstration purposes, and the other that builds it. And then we have a set of tests that essentially run some benchmarks. So if we didn't have dependencies, each of the, for example, OSU latency or OSU bandwidth benchmarks, we would have to download and compile every time the OSU benchmarks, which is not efficient. So in this example, I'm going to show you how we split that into dependencies. And let's start, and let's start gradually. So one thing is here we have mixed up the tests. There's no, the order the tests are defined, doesn't matter. And just to prove that, they're a bit mixed here. So the download test, I think it's at the end. So here is, everything. So we wget essentially, the test just executes wget post run, and then just runs the untarget. And this apparently only runs on the login node with a built-in environment. Now, let's go to the build test. So build test here. So for the build test, let's also adapt it. And here we need the FOSS. So we say that it depends on the download test fully. So we can't proceed if download test. I mean, we could, yeah, we couldn't omit that. So because they run on different partitions. So we say just, we depend on also download test fully. So we can't proceed if it has not executed, all its test cases have executed. Then you see now another example of build systems. We're saying we're using auto tools. Yes, use make -J8 and yeah, check for errors. And now how, for example, okay, we depend on another guy, but how we use the result of that other guy. Now this is, again, you can do that with this pipeline type of hooks. With another type of decorator. So you define your own function. Here we call it set sources dir because we're going to set the sources dir of our test. And here you put the name of your target dependency as an argument. And that decorator does some magic here so that you can essentially binds that thing to a special function that you call essentially to retrieve the actual dependency. Let's say it in practice before, because it's better if. So here we say, okay, from the also download test case, from the also download test, I want the test case that has run on the login partition with the built-in environment. And from that, I want the stage dir, which then I use to make up the path and set my own sources there. Now, the nice thing about this is that this call here really gives you access to the actual test case that has run. So to another test. So you have all the information of the target's test, even its num tasks, all these things for the target test, you have them at the state that it is after it has finished this execution. So you can really, yeah, stretch your imagination with things, for example, that you can do. It's really, really flexible. But here we just take the stage dir, that stage dir, the target one, and we combine that path, which is the download path essentially, and we set our sources there. That's what the build test does. Now let's see the different tests. So yeah, then we have the latency and bandwidth test. And since they're very, very similar, we created a base test here. That's also a practice that you can use. We use it a lot in our tests, where we define everything that's common. So the valid system, let's add our guy here. This guy doesn't set the sources there because it's going to be set. No, this is a run only test, so it doesn't matter. So I'm not having any resources. We set by default num task and num task per node, and then we set the sanity patterns and our dependency. So whoever inherits this test, it will depend on the build test. So here is the latency test. We just put in the description. Yeah, we inherit from our base class. Put a reference with this generic way, so just to have the units that I showed you before. And then we set the executable. So now the executable, we should take it from, it's generated by the build test. So again, we use the same trick here. So we, one thing I didn't mention that when I was talking about dependencies. So here we say we depend on the build test by environment. So that means that the test cases between partitions are independent. But if I'm running with FOSS, I want that the build test that has run with FOSS to finish, but I don't care if the build test with Intel or PGI has finished, for example. I will proceed as soon as the build test of FOSS will finish. If we didn't have this granularity here, then you would simply have to wait, for example, for the Intel test to be built, and that could be And imagine you have a license server with few licenses, and that you would block your whole sequence of tests. So again, the same trick here. So here I'm not passing anything, because if you don't pass anything, ReFrame will pass the current system and the current environment, the current partition, the current environment. So no need to pass here anything, because we will be relying on ReFrame, CN, and on FOSS. And then I'm just constructing the path where the OSU latency benchmark executable is. And I pass also the executable options. Exactly analogous is the bandwidth test, like that. And then for the OSU all reduced test, which is exactly analogous, except that for this case, we said, okay, let's be a bit more imaginative and make this like a scaling, scale it on different number of nodes. So we parameterize the test. Again, each of those tests will depend on the build test. So it's what I really like is that it's really, really composable. Okay, let's see first. Let's list the test, because there's also some interesting things here. Okay, we've said all of those stuff. Let's list the test. That's the whole thing. Okay.
The download test doesn't have a valid system.
Which one? The yeah.
Part.
Which one does not have?
The download. It only lists.
It doesn't. Oh yeah, you're right. You are preferred. Perfectly. Okay, let's see if we have put it everywhere. Yes, yes. Okay. And also benchmarks. Let's see what we're gonna get. Okay, that's a nice sign that it has listed everything. So the list option is also a bit smart, especially if you want to work with dependencies. So I'm gonna just pick, let's say the OSU bandwidth test, right? And I'm gonna list it. So here it says, it instead of listing just the OSU bandwidth, it listed also all its dependencies, because if you want to run OSU bandwidth, you have to run its dependencies, right? So it automatically picks them. Now,
it doesn't list them in dependency order. It just lists them.
Yeah, exactly. It just lists them. It's random, the order. Now you might want to see also bandwidth. If you make uppercase L, you will get more details about the listing. So again, you get your 3 tests, but let's go a bit to, let's take one by one. Let's start with a basic one. Again, they're not in order. They're not in topological order here. So no download test, yeah, nothing, no dependencies. Build test. Okay. Now dependencies. So you have the conceptual dependencies, which is on the download test, and then you have the actual dependencies. The actual dependencies may change depending on the system you're running and depending on the programming environments you're running. But here you get the exact graph, essentially, the edges in the exact dependency graph. So, so it says that the build test on CN with GNU depends on the download test on the login with built-in, and similarly here. And the reason that this cross dependency, you see, it's not like the classic one that you had depend on ReFrame, EUM, CN here, and GNU, is because we use the fully dependent property in the how argument. So then you say, I depend on whatever you do with download test, I have a fully connected subgraph between those 2 cases. So here you get the actual dependencies. And for the bandwidth test, you see, I depend on build test, but here you see it differently. So you see, we had this by environment. So I depend on the ReFrame, EUN, GNU, and CN, and FOSS, and CN, and FOSS. And actually, I believe that we could even, be specified. We didn't even have to pass the how argument to this guy. But let's run first and then. Okay, so let's run everything. I remember we had a small problem with the cluster, I remember. Okay, let me just run. Okay, no, I will run everything. So let's see with the messages. So when a test is kind of blocked due to dependencies, ReFrame prints a dep, a message, and just go on to the next. This is how the synchronous policy works. If you are on the serial execution policy, it will just block until the dependency has finished. Yeah, it will take some time now to build.
Well, we'll need to wrap up the recording and the stream soon. So maybe
yeah, okay. So
if there are questions that people want to ask.
Yeah, please go ahead, because I don't have anything more with the dependencies. Simply, okay, I would just run the bandwidth here, and I can take any questions. Yeah, we have one.
Hi. So with a simple HPC system where you have built your modules using EasyBuild, for example, how would this thing work for the dependency test? You already sort of, you don't need to sort of download stuff. You have already installed, let's say, OSU benchmarks.
Yeah, I mean, there can be different scenarios. I don't know, when you want to, structure your run-only test, that they, for example, I don't know, you don't want to run something if not something else has passed.
Right.
It's
orthogonal. You give me an example. Allow me to give an example. I have one.
Yeah.
So what I do is basically, it makes no sense for me to be running a GROMACS test if the version of GROMACS is wrong, if the minimal things of GROMACS is not passing. So what I do, I basically use the module load of GROMACS and I check if actually the versions are correct, if the inputs are being correctly constructed. And after that, and then I go run GROMACS. So they have like the actual run depends on the input creation and then also the input validation step.
Got it. Okay.
Yeah. So let me explain you what I'm doing here is that I'm removing the GNU environment if I am on ReFrame EUM system, just because it doesn't make sense because there's no MPI compiler there. So that's why I'm doing that. And yeah, any other question as I fix the test?
Another example, if I may add, is that even though you can have EasyBuild things, you can still have like compile only tests and also compile and completely reframe tests. Imagine that you have built HDF5 with EasyBuild and you want to test HDF5 is working. So what you do, basically, you do first you download the test and you compile it, and then you run several HDF5 different tests based on that initial one.
I think that brings up an interesting point. I mean, if I actually want to build using EasyBuild in the ReFrame,
Victor, you are the.
I've done that.
You are the one to take that.
I have a test of EasyBuild that actually, because I'm responsible for GROMACS at CSCS. So what I do is basically I generate on the fly using EasyBuild, using ReFrame, EasyBuild recipes, and then I compile all the different versions of GROMACS with PlumD, with instrumental version with CratePad, and then I do all the testing, and then after that I run all the tests, right? So I have experimented with the EasyBuild installation with ReFrame, It works really well, but currently on this sprint, we have a colleague of ours, Rafael. He's actually working on getting a proper build system for easy build. So you can do that system.build system equal easy build, and then voila, and it's actually gonna call and do everything for you.
I would love to see that. I mean, that's like exactly my use case scenario, and would love to see when you guys have that available.
So I can point you because that's an interesting. We have a draft PR. It's really he just pushed. So I don't think if it's working yet, but. So if you want this thing, because we're gonna do, okay, let me just make this bigger. Yeah, so the idea is, yeah, if as soon as it becomes a bit more mature, I think soon, I mean, it would be very nice if you try this out or do some comments, because the idea there is that yeah, so you say as self.build system equals easy build, and then you will have ReFrame, yeah, use easy build to build something, but not to install though. It's gonna do it how we have it in mind. It's gonna use easy build to install it in a stage directory of ReFrame, and then you use that for testing, and then you have to figure out some machinery there so that you load the modules automatically and sets out the module paths, etc. But all this is going to be handled automatically by the test. That's the idea. And we plan to do the same also for SPAC. So you can have build system equals SPAC and have ReFrame do the.
Awesome.
Yeah, I mean, Vasily said that we envision to install in the stage directory, which is going to be the default, but you can also self variables and change the easy build prefix and change the path you can install it, right? So you can still using this build system change where to use ReFrame to drive your installation to the global central repository or whatever installation of your cluster. But I have to say something about this because I mean, the reason why I don't have my test online is because my test spawns in practice more than 3,000 ReFrame tests of GrowMax. Right, if you really take into account all the combinations of versions and instrumented, non-instrumented, with PlumD, without PlumD, then it just like goes crazy. So you have to be a bit careful with the
regarding parameterization. Regarding test parameterization, there is a very, very cool feature that we just put in 3.4. We have only basically documented. We have not a tutorial about it yet. But it is documented here, and it's the direction where we're also going for this library of tests. And so there is a section here called directives. That's new. We should have put it here, the new in version 3.4. So instead of doing parameterized test, the idea.
Vasilios, I'll quickly interrupt. I'll end the stream here on the recording. But you can keep going in the Zoom session. So
okay, yeah,
do that first.
Yeah, okay, thanks.